Imagine you're the Minister of Communications. The President wants the country offline in 10 minutes. Where do you start?
First, stop hunting for a magic switch. The internet isn't one system. It's thousands of networks that agree to cooperate.
And yet, watchdogs counted at least 296 shutdowns across 54 countries in 2024. So how do governments do it? Fast. On the map behind me, Iran and Tanzania are just 2 dots. But the playbook is bigger than any one place.
They don't turn off the internet. They force choke points to change behavior. 3 levers: the pipes, the names, and the routes. The map that tells traffic where to go.
So we're going to reverse engineer a blackout, one lever at a time, until a whole country looks like it vanished.
Exactly. And the first move isn't code. It's a phone call, an order, delivered to the right operators. There is no single off button in a presidential palace. The internet is decentralized globally, but locally, most people reach it through a small number of networks.
So if there's no button, how do they actually stop it?
They use the chain of command. Step 1 is the phone call, an order to the companies that run the connections people actually use. Internet service providers and mobile carriers, the physical pipes and the radio towers. On that diagram, it's the few big boxes in the middle that everything funnels through.
And they just listen? Why would a company cut off its own paying customers?
Because they operate by permission, licenses, spectrum, permits. If the regulator says comply and you refuse, you risk losing your license, getting fined, or having executives targeted.
Has this actually happened recently? Or is this just theory?
It happens. Look at Uganda. January 13th, 2026, 2 days before the January 15th general election. The communications regulator ordered operators to suspend public internet access, citing national security concerns, misinformation, fraud, and incitement.
So everything went dark, a total blackout.
Not exactly. It wasn't a power cut. It was a policy cut. Block most public traffic and keep a tightly controlled whitelist for essential systems. So hospitals, banking rails, government platforms, those can stay reachable for authorized users. But for the public on the map, if you're trying to message, post, stream, your internet feels dead.
That sounds surprisingly organized. Is it always that clean?
Sometimes it's blunt force. In Egypt, 2011, the major providers effectively withdrew their routes. So from the outside, Egypt largely vanished from global routing. The country fell off the digital map. Whether it's surgical or a blackout, the mechanism is the same. You squeeze the choke points.
Okay, so they have the ISPs in a vice. But what if they don't want to kill the whole connection?
Then you move to step 2. You don't kill the line, you make it painful. We call that the soft block. Step 1 was the phone call. But a total blackout is loud and expensive. Step 2 is quieter, the soft block.
Soft block? So the internet is still on, just bad?
Exactly. We don't cut the line, we squeeze it. Throttling, like that 16-lane highway shot where 15 lanes mysteriously vanish.
So cars can still get through, but it takes forever.
Right. Russia did this to Twitter in March 2021. Researchers measured targeted Twitter traffic effectively capped around 128 kilobits per second.
128 kilobits? That's basically dial-up.
Text might limp through. Images crawl. Video is effectively dead. People give up, while you can still claim the service is available.
How do you target just one app without slowing down the whole country?
Traffic classification, often using deep packet inspection or DPI. Even with encryption, you can still identify patterns, domains, IP ranges, handshake signals. Then you shove that traffic into the slow lane.
Okay, so that's speed. What is the second lever?
We attack the address book, DNS interference.
Remind me how DNS works again.
You type a name, your device asks DNS for the number, an IP address. That lookup chain is what you're seeing on screen.
So if you control the DNS,
I control the map. I can say, no such site. Or I can answer with the wrong address, send you to a block page, or nowhere at all.
you lie? You send them to the wrong place?
Exactly. Look at Turkey on February 8, 2023. After the earthquake, Twitter access was restricted. On some networks, it was throttled.
And the others?
They used DNS tampering. People tried to reach Twitter, and the DNS answer came back as 127.0.0.1.
127.0.0.1. What is that?
That's localhost, this device. Like the diagram, the network tells you the destination is inside your own laptop, a digital dead end.
Can't people just use a different address book, like Google's public DNS?
They try. Then you block or intercept that too. DNS over port 53, encrypted DNS, whatever's popular. It becomes cat and mouse.
Is this happening anywhere right now?
Yes. In Iran this month, January 2026, monitors reported engineered disruption signals, like a sharp collapse in IPv6 reachability, alongside broader connectivity loss. That's the layered approach. First, a protocol stutters, then mobile data degrades, then the screws tighten.
Why go through all this trouble? Why not just pull the plug immediately?
Plausible deniability. If it's just slow, you blame congestion, a technical issue. You can even joke that a shark bit the cable.
So it buys you time.
It buys you cover. But sometimes, the soft block isn't enough. People find workarounds. VPNs route around the damage.
And when that happens?
Then we stop playing games. We go to step 3, the nuclear option. We make the country disappear from the map entirely. Step 2 was about making the internet painful. Step 3 is when the outside world can't even find you. We call this the hard block.
Disappear? Like cutting the undersea cables, like the lines on that map.
Those cables are real, but you rarely need to touch them. You can pull the routes instead. The internet runs on something called BGP, the Border Gateway Protocol.
BGP. That's the address book we talked about.
No DNS is the address book. BGP is the roadmap. It's the part that tells other networks which direction to send traffic. In a hard block, networks withdraw their BGP announcements. To the rest of the internet's routers, those IP prefixes simply stop existing.
So if I try to visit a website hosted there, my computer literally doesn't know which way to go?
Exactly. The name might still resolve, but the path disappears. Your packets hit a no route dead end. We saw how fast this can move on January 8, 2026. Monitoring showed Iran's announced IPv6 address space dropping about 98.5% around 1150 UTC. Minutes, not hours.
That's terrifyingly fast. On the chart, it looks like a heart monitor flatlining.
And not every failure is that clean. Sometimes the control plane, the map, still claims routes exist, but the data plane, the traffic, can't actually flow. That's a classic gray failure. But in a full hard block, it looks like Syria on November 29, 2012. Traffic falls off a cliff, and analysts see widespread BGP withdrawals. That's the point. Isolate a country from the global internet.
So soft blocks make it useless. Hard blocks make it unreachable.
Correct. When a country goes dark, it's usually not a glitch. It's coordinated, and it shows up first in the routing map.
So, just to be clear, there's no single worldwide kill switch, no button in a bunker.
No global button, just a few local levers. Control the choke points, and you don't need one. You squeeze the pipes, the ISPs and upstream carriers. You poison the names, the DNS resolvers. Or you scramble the maps, the BGP routes. That's what we're looking at on screen. Pipes, names, maps.
And this isn't theory. People are doing it?
Constantly. Access Now documented at least 296 shutdowns across 54 countries in 2024 alone. And it's not ancient history. On January 8, 2026, multiple monitoring groups saw Iran's connectivity collapse into a near-total blackout, traffic dropping to near zero. That pattern is consistent with an intentional shutdown, not a random outage.
That is terrifyingly simple.
The network is built to route around broken hardware, not around a government with authority over licenses, carriers, and gateways.
Message received. Thanks for the briefing.